Good evening, guys. I hope I'm audible to everyone. So, I welcome you to the last session that we'll be having with VIP program with machine learning. So, I hope everyone can hear me what I'm saying right now. And in the next few minutes, we'll be starting the session. I'll wait for a few more minutes so that everyone joins. We are participants of 7 right now. Sorry, 17. We're at a count of 17. So, let's wait until it passes 25. And I want some responses to know that I'm audible to everyone. Give me some responses in the chat that I'm audible to everyone. So good evening once again, everyone. I hope I'm audible. So please give me some response that am I audible or not. And I can see there are only 22 participants right now. So just give me a quick confirmation that shall we start the class or shall we wait some more time so that everyone joins? And sometime if we are getting delayed, can take the class until 8:20 or 8:10 or some other time. But do we need to wait some more time for the remaining participants or shall we start the class? I need some response from you guys. And give me a quick confirmation that you can see my screen. Guys, I need some quick confirmation that you all can see my screen. If you all can see my screen, then we can start the class. So I hope this is the place where we have left in the last class. We're talking about until we have split the testing, the data set into testing and training. Now we'll be starting with algorithms. So we'll be discussing about linear regression. And after that, we'll be discussing about data descended regression, and also we'll be discussing about random forest regression. Okay, so we'll be discussing about random forest regression, and also we'll be discussing about AdaBoost. After that, we'll be going with stacking. So yeah, we'll be having a small recap about Canon also. But in the meanwhile, and then we'll be talking about stacking. So I'll be explaining you stacking this at a boost, this dysentery regressor and random forest regressor, everything in detail. So we're already delayed by 20 to 30 minutes. So let's start the session. So if you look at this thing, now we are talking about linear regression. So I hope everyone knows what is linear regression. I need some response from you guys regarding the linear regression that we have discussed in the previous sessions. I need some response in the chat regarding the linear regression that we have discussed in the previous sessions. What is linear regression? In what cases we'll be using this thing and everything? You can type anything you remember regarding this linear regression. I need some response that you remember what is linear regression and what is this used for. Guys, whoever present in the chat, please give me some response regarding this linear regression and other topics. So getting into the session, let's not waste time. So I'll explain you what is linear regression again. Okay. So, but give me a confirmation that do you know linear regression or did you forget anything about linear regression or some other thing? Okay, then this model what we'll be discussing is called as linear regression. Our first model we'll be doing today. So linear regression tries to find out a straight line relation between our initial, like our input features. So what is our input features? X, and our what is the target feature that we're having? The target feature that we'll be having is Y. Always remember that X is independent and Y is dependent. Okay. So we'll be discussing about the linear regression, and also this linear regression, what it does is it tries to fit a straight line relation between our input features and the output variables that we'll be having. It's like drawing the best fit line throughout all the data points. Okay. So what are the data points inputs we're taking? It's like taking a line that is nearer to all the data points. Okay. So that is what linear regression is. So if you look at this, linear is equal to linear regression. So we create an empty linear regression model here. We are creating an empty model here. We are calling this linear regression model. And the next line, that is LR underscore model, is equal to linear dot fit. This is the training step what we're doing. It is like drawing the best fit line throughout the data points. Okay. It is where you start drawing the points. Now here we'll be having some math behind this function and everything. Okay, now y underscore pred is equal to LR model dot predict of X test. After training, okay, whenever what you're doing, first you are defining, and after that you are fitting the thing. Okay, after that you are fitting the thing. After that, what you'll be doing, you'll be predicting. Okay, so what this does is after training, we use our training model to predict on X test. Okay, this is what testing variables are. Okay, now this is what these testing variables are. After that, we'll be comparing these predictions with Y test. Okay, so if you look at this, Y predict is equal to LR underscore linear regression underscore model. That is what we are doing here. Dot predict. We are predicting values. Okay, so meaning it learns the coefficients what we are having. Okay, it learns the coefficients and intercepts for the best equation that we'll be finding. Okay, and after that, what are the unseen data that we'll be having? This is unseen data. Okay, so coming to X train, Y train, these are the seen data. Model is trained on this data. But coming to X test is the testing data that this model is not seen until now. So what we'll be doing is, we will, whenever you click on this, whenever you like give this X test, this is the unseen data that we'll be having. So now look at this. We compare the predictions that we'll be having between this X test and Y test. Okay, so that is what we'll be doing right now. And coming to the next thing, here we are R2 underscore train is equal to LR model dot score X train Y train. And after we are like having a function to intercept. So this is where we are using the metrics of R2. Okay, now here using this is the R2 squared score on the training data what we'll be having. So this is what the both training data is. X train and Y train are the training data. Okay, so X train and Y train are the training data. So whenever you're doing this R2 is it's a matrix that will be performing upon X train and Y train. So R square tells us the proportion of variance, the target variable that our model can explain. How much of the variable that our model can explain, that is what R2 is. So a higher R2 square is generally better, and it's called better fit. Why we are calling this higher variable better fit? Because whatever the variables it is explaining will consider as a count. Okay, whenever the count increases, the model can explain every feature, why it is coming like this, and how can I interpret whenever a new feature comes. That is what R2 does. Whenever we are having high count, then we'll be having more number of better outcomes in the further. So in the next line, what we'll be seeing is intercept. Now what we're doing is we are intercepting. So the intercept is valid for when all the X features are 0. Okay, remember this thing. The intercept is a value of Y. Whatever you're doing, the intercept is a value of Y, what you're doing. And when all the X features are 0 in real world context, this is the baseline that if all other factors were at the minimum scale values. So this is what this intercept is. And coming to slope, here slope is equal to linear regression underscore model dot coefficient. So the slope is nothing but the coefficients. Tell us how much Y is expected to change for 1 unit increase in each X feature. So as X is independent, so Y is dependent on X. So whenever a X value changes, how much Y changes and how much Y is dependent on X, that you'll be seeing in this slope. Okay, so what are the things that will define the change in Y is called this slope is equal to LR dot model. So this is its function that we're calling right now. Here you can see here we're calling this auto train. We're just calling this function. Now what we'll be seeing is LR, linear regression of root mean square error, LR, mean square error, LR, mean absolute error, and last thing that is mean absolute percentage error. That is LR, linear regression of mean absolute percentage error. So for everything you're having a function. So mean squared error, mean squared error. I think we'll be having a root mean squared error right now. So LR of mean squared error, LR of root mean squared error, LR of mean absolute error, LR mean absolute percentage error. And for everything you're taking y test and y prediction. Okay, now we are taking y test and y prediction values. So when you look at everything in detail, so what is this MSC stands for? And what is RMSC stands for? When you look at this thing, RMSC, that is root mean square error. This is a very common metric that we'll be using. It measures the average magnitude of all the errors. It's same as our target values, what we'll be saying, but it is lower whenever we are having this lower RMSC, it is better values. And also, whatever the RMSC and MSC values, they're mostly slightly the same. So what are the MSC that we'll be having? Mean square error. It is similar to RMSC, that what we're discussing right now. But what are the average that the squared errors that we'll be having? So squaring emphasizes larger errors. So whenever you're taking RMSC, we'll be having lesser values. But whenever you're taking MSC, you'll be having greater values. So coming to this both things, RMSC and MSC, whenever you're having lesser value, that will be better, because whenever the mean squared error and absolute mean squared error, that means whatever the sorry, whatever the training data and whatever the testing data, but whenever you're comparing, what is the metric error, what will having between those two values, that is called as mean squared errors and root mean squared errors. So whenever the errors are very small, then we'll be getting better outputs. Okay. Also coming to mean absolute error, this measures the average absolute difference between predicted and actual values. It's less sensitive to outliers. That also lower MAE is better. Okay, so just like RMSC, MSC, and other metrics, MAE also prefers lower values. Okay, whenever we're having lower values, our model will be better. So coming to the last thing, MAP, that is mean absolute percentage error. This expresses the error as a percentage of the actual value. What are the actual value that you're having? For actual value, we'll be having an error. So how much of an actual value that you're having error, that we'll be seeing this. So we print out all the things, and after that, if you look at this R2 underscore test, now what we're doing is here until now we have predicted the values on trained values. That means until now, whether the model is trained on these values, then only we are performing this metrics. But coming to this X test and Y test, we are performing this on new variables. Okay. So what are the R2 that we're having? That is that is what are the metric that we'll be having. This is performed on new values. Until now, if you look at this cell, in this cell, we are performing on the seen values. That is seen data that is model has seen this data before only. But coming to this X test and Y test, this data the model didn't see until now. Okay, so this data the model didn't see until now, and the model will predict the values that we'll be having. And coming to this thing, here we're printing all the metrics that we'll be having. So R square, intercept, and slope. Okay, so we're calling these functions, and here we are predicting the values. Print root mean square error, mean absolute error, mean absolute percentage error. If you look at this, we are getting a value of 350820079. Excuse me for a moment, guys. Thank you for the response, Anjali. I didn't see that until now. I appreciate your response. So where were we? We are just discussing the values that we're getting, right? So coming to the values, root mean square error, mean absolute error. So what are the values that we're having? We'll only have the better accuracy when the values are later, not the accuracy when you having the better outputs. When we're having less outcomes, that means less number in this root mean square error, and mean absolute error. Coming to the feature count, what we are having 7 features as discussed above. What are the columns that we're having? That call as features. Now, we'll be having 7 features that were just shown right now. So now here we have defined a function adjusted to score model, and in this model we adjust to score. In this we are taking model x and y as an input, and we are taking R to score is called model of score of x and y, and it's called to x of count. So what we are doing here is we are adjusting the R square. What are the R square that we are having? We are adjusting it. So even if you look at the below code, below cell, now what it describes is, well, R square is good. It can sometimes be misleading if you add many features to the model, whatever you're having. So if even though features doesn't genuinely improve the fit, what are the features that we're having? If it does not have help us in the better way, so what it does is adjusting the R square accounts for the number of features in the model what you're having. So it only increases if the new features generally improve the model more than would be expected by the chance. And also, we'll be having a formula that you can see that right now. The formula that we're having is 1 minus, and that inside we'll be having 1 minus R square into n minus 1 slash n minus p minus 1. Now, if you look at this, R squared is 0.64 and n is 935 minus 1. You can see that, and 935 is divided again, and in the place of p, we'll be having half. So here, this f count represents number of features. Okay. So here, if you hover this, you can see that the 7 count as 7. That is what we are seeing right now. Okay. So I hope you understood this formula. Remember this R2. What is the formula that we're having right now? So this adjusting R square formula is called, this is the adjusting R square formula. So the formula is 1 minus R square whole square. Okay, 1 minus R square into n minus 1 by n minus p minus 1. Okay, so that is what we'll be having for testing and training. This adjusting R square is calculated but for both the testing and training data sets, and also you can see the values that we're having. Okay, here we're printing the values and we're appending the values. So the values that we're having for R2 after adjusting is 0.63 and 0.69. And after that, for this values, we'll be having a scatter plot of a PLT. That is PLT, we will be having this PLT whenever you use this matplotlib. Matplotlib.scatter, we'll be having a scatter plot. So this scatter plot of actual or predicted values is a greater visual check. What will be seeing? So we plot y test values on the x-axis and y predict values on the y-axis. So if our model was perfect, all the points would be exactly on the same diagonal where y pred equals y test. Okay, so the closer the point clusters around the imaginary diagonal, the better model predictions will be. This is what the chart describes, and also as we have discussed right now what it is, whenever we're having the better model, the closer the points will be. And coming to the next thing, now you can understand that we have just now developed a linear regression model. Okay, I just now developed a linear regression model. This is what you will be seeing. Now we'll be going with decision regression. Okay. Now we'll be starting with decision tree regression. The first thing that we are going to do is linear regression. That is the first model that comes to your mind whenever we think of regression. the next model that we'll be seeing right now is decision tree regressor. Okay, so going with the model, what is decision tree regressor is? So what this decision tree regressor is? So I'll be explaining right now. Imagine you're having a series of if-else questions. I hope everyone knows Python. So what are the if-else questions that we'll be having? So if this happens, we'll proceed with this output. If not, we'll go with the else output. So that's what if-else is. So imagine you're having a series of if-else questions. A decision tree learns these rules from the data to make predictions. For example, if age is greater than 30 and smoker double equal to yes, then predict charges is equal to x. So what are the instances that you're having? So if the age is greater than 30 and also the smoker, if he's a smoker, if it is yes, then predict the insurance charges that will be around this x price and there's something like that. Okay, so that is what this decision tree regressor is. So if you look at this code from explainer, we are importing this tree. Okay, so this is what the decision tree library what it is. So the next thing is k-fold. Okay, so k-fold, n-splits, shuffle, random set. So I hope you know what is this shuffle and what is this random set and the splits what we'll be using. So what we are using this in this decision tree regressor format is, so this sets up k-fold cross validation. So what are the k-fold is? This sets up the k-fold cross validation. So instead of single test and train split, what we're doing in the above model, we'll be using multiple test and train. So k-fold divides the training data into n splits. So here we are taking the n splits as 5. So it is dividing this into 5 splits. If like it then trains the model 5 times, each time using a different segment as a mini test and the resting as training set. So it gives us a more robust estimate of performance and helps us overfitting. So helps us prevent the overfitting, not overfitting. Helps us prevent the overfitting. So what is this and how this work is? So we'll be using the help of, let me just show you with the whiteboard how this cross validation works. I hope everyone can see the screen. So I'll be explaining what this cross validation is right now. So imagine this is the training data set what we are having. Okay. Now based upon the program, so it is saying that we are having a splits of 5. N underscore splits is equal to 5. Now this 5 represents the split what we'll be having between the data. So imagine whenever you're training data, what you'll be doing before it was something like this, right? 0.7 for testing, 0.7 for training and 0.3 for testing. Whenever you're using 0.8 for training, 0.2 will be testing. So I'll be telling you some hypothetical situations where some scenarios may arise. So what the situations is? Suppose what are the data you're having? The complex data will be in this thing. Okay. Now whenever you're having complex data, this will be crucial for training or for testing. Okay. Whenever you're having simple data, this might be useful for testing. Okay. So I'm not saying that this testing data is entirely for, that simple data is not for entirely for testing. We need a part of that for test training also. So what we'll be doing is we need a cluster of complex data and also a cluster of simple data. Not every data that we'll be taking in the future will be simple or will be complex. So we need to train our model with better accuracy so that whenever the future outcome comes with a complex solution, we need to find the solution with less response. So what we'll be doing is this cross validation solves this problem. So what are the problem that we're having? So if it is 0.8 and 0.2, what if the 0.2 is simple data? Okay. And whenever I give some new output, that means whenever I give some new input, that is y, So this, if it imagine this is a complex input, so then the model will stumble to predict this output, because what are the testing that you have done? If it is done on simple data, even though the model is not capable for doing the outcome, so predicting the outcome or doing some regression task, we'll just deploy the model. Okay, now whenever a simple a simple new variable comes, it will easily find out the output. But whenever a complex variable comes, okay, that is what the situation that we are handling right now. Whenever a complex variable comes, it is very hard for the model to interpret and understand. Now that is what we'll be thinking right now. We need a 0.5 of complex and 0.5 of simple. Okay, now this will help us identify all the patterns, all the logic, all the algorithms in this data. So based upon this, we can understand what is cross validations. Cross validation will overcome this problem. So what it will do is it will divide the data into 5 different parts. Here it is 1, it is 2, it is 3, it is 4, and it is 5. Now what we'll be doing is whenever whenever n comes, one from among the 5 will act as testing data. So at first time it will act as testing, and remaining all will be training. Okay, this is use case number 1. Use case number 1, training, testing. In testing, we'll be using 1, 2, 3, 4, 5. Okay. Now coming to use case number 2. Now what we'll be doing? Now here we'll be taking second one as testing. In this place, we'll be taking second one as testing, and the remaining. So instead of this entire remaining will be, the entire remaining will be this will be taken for training. Okay. Now, if you look at the data that we are having, so this says that for training we are using 1, 3, 4, 5, and for testing we are using 2. Likewise, this order changes every time. Okay. Now, at third time we'll be using this for training. We'll be using this for training. Sorry, we'll be using this for testing. We'll be using 4 for testing, and we'll be using 5 for testing. Okay. So the remaining things that you're having whenever the testing outcome comes, so it is 1, 2, 4, 5. 1, 2, 3, 5, and 1, 2, 3, 4. So this is what the cross validation does. So we have got the split. Now what we'll be doing is we will train the data based on 5 use cases. We'll train the data based upon 5 cases. Okay. So instead of training the data in one single use case, we'll be training the data in 5 use cases. So our model will be trained well efficiently. So whenever, even in the future, if we get a complex pattern or complex input, we'll be solving that with minimal effort. Okay, that's what we'll be doing with the help of cross validation. I hope you understood this thing. Give me some response in the chat, guys. If this cross validation is not understood, please let me know. I'll try to explain another way. Class, I need some response to continue. And I hope you all remember that this is the last session we'll be having, and don't waste the time right now. Thank you, Anjali, for responding. Now we'll be seeing this dictionary regressor. Okay. Now coming back to the topic where we were. So after this split and everything completes, we'll go to the next thing, that is grid search. Okay, now using params as grid. So what this grid search is? Okay, now this grid is nothing but grid search CV. What we're seeing is this is a powerful technique for hyperparameter tuning. What we'll be doing. So hyperparameter tuning are setting for our model that aren't learned from the data, like maximum depth in dictionary tree. So grid search CV systematically tries every combination of parameters. So that is defined in param grid 2. So what is defined? Like example, Look at this: minimum sample split, minimum sample leaf, and maximum depth. Okay, so what are the example? Let's take an example of maximum depth is equal to 3 with minimum sample leaf 10 and maximum depth 4 with minimum sample leaf 10. So on. Whatever the things that we're having. So this 10, 51, 10. Okay, this is minimum sample, minimum split, minimum leaf. Okay, so based upon this thing, we'll be dividing the every probable outcome that we'll be having. We'll be having multiple outcomes where we'll be testing our data with one another. Okay, so the next thing we'll be seeing is scoring is equal to R2. So we tell grid search CV to use this R2 squared sort to evaluate which combination of hyperparameter is best. Whenever we are showing this grid search, I hope everyone understood this what is grid search is. We'll be having every possible outcome. So just like what I've done is with cross validation, cross fold, K fold, like K cross fold validation. So just like that, we'll be using this thing. So in this thing, systematically tries every combination of parameters that is defined. So every combination that we'll be trying, and it will be telling that best outcome. So out of the best outcome, we'll be selecting only the features that we got best. So out of these best features, we'll be using them for the input, and we can perform the operation. Okay. Now here in the second thing, that is grid underscore CV, DT, param grid 2, and the CV is equal to KF, comma scoring is called R2. So here, whenever the R square score evaluate, so this R square score R2 square will evaluate the best best input for the hyperparameter tuning. After hyperparameter tuning, what are the best thing that we'll be having? We'll be taking that as an input. So next thing is grid underscore CV dot fit x10 xy. So what are the thing that we'll be seeing after grids, like the grid search? What are the values that we'll be having after the best outcome that we think it is? So we'll be training with the help of this grid search. Now we can, when you click on this also, you'll be seeing something. You know, see, this is what this is. In maximum that we have taken is 4, minimum sample is 10, and minimum samples of 30. So what this best estimator is. So if you look at this, it's the same thing. So if you look at this, we'll be seeing the maximum depth and everything. Okay. Now if you see the functions are defined earlier, n splits is equal to 5, shuffle true, random set 42. N splits is equal to 5, shuffle date, random set, and shuffle date is equal to 2. So maximum depth 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. This is what the depth is. And the leaf arrays what we're having is 10, 30, 50, 70, 90. And the minimum leaf split that is 10, 20, 30, 40, 50. This is what the grid search has done. Okay. So after grid search has done, it will process with every alternative outcome, every probability of a systematic combination that we'll be having. So it will try with that and it will give the best outcome. So after that, we'll be training the model with this thing. Okay, we'll be training the model. After that, you can find the best score. After that, you can find the best score, that is grid underscore CV dot best score that you'll be seeing with the help of here. So R square, what you'll be having. So R square will tell the best model found by grid search. What are the grid search that we'll be doing? This R square will tell the best search. Now also this best params, what are we having? It will also tell the best params and best estimate. So what are the grid search that we're having? The actual trained model object with the best like hyperparameters what are we having. So it will be told in this best eliminator, sorry, best estimator, and come to the best params. So which combination is very best for the training that we'll be using, what we'll be seeing in best params. So remember, best score is the R square, like R square score that we'll be seeing. Okay, best params is the best combination that we'll be having, and best estimator is the best inputs that can give for a model from this hyperparameter training. This whole process helps us finding the optimal settings for the decision tree rather than just guessing whatever we can get from this decision tree. So rather than just thinking about this decision and making some predictions, so irrespective of these predictions, we'll be having these mathematical functions. So based upon these mathematical functions, we can run our code and we can get the best output. So after that, we're initiating a decision tree regressor with the best params found by grid search CV. What are the thing that we have found that is found by grid search CV? So we are initiating that thing. And also, this ensures we are using a well-tuned model. As we have done this hyperparameter tuning, we will understand that whatever the model we are using is a well-tuned model. And then we fit the model to train data and calculate the R-square error. What we are doing is we are then fitting the data. So if you fit the data, we'll be understanding what is the best value and everything. So scatter the values that we'll be having for R-square of X test and Y test. So same values that we'll be having it dictionary for X train and Y train. So the values are 0.85. This is 0.85, that is 80% accuracy that we have got. So compared to test values, we have got around 0.87. Okay, so these are the accuracy that not the accuracy, the metrics to find out the R2. So you're having 0.85 and 0.87. So for on training data, you got 0.85, but for the computation data, you got 0.87. Coming to this thing, we are predicting X test. Okay, we are predicting X test and we didn't call the values. So here we are taking the inputs as the DT of RMS is root mean square error. R2 is square error, mean absolute error, mean absolute percentage error. What are the things that we're having? We're taking Y test and Y train, Y test and Y prediction. So after that, we're printing the values. So what are the values that we got with R test and R2? So that is what we're printing here. RMSE, R2, MAE, and MAP. So these values will tell us the outcome and the accuracy or the precision, what will be from the precision or the metrics that will be telling us what is the best output and what is the worst output for every model, for every with every metric that we'll be having for machine learning. So you can see these values that we got. Arts means per error, it's around 18,000 or some other thing. And coming to mean square error, mean absolute percentage error, these all values are defined here. So going down, we can see there's a plot right now. Okay, so this plot is being developed same as a linear plot what we have discussed below. So here you can see in the x-axis we have charges, in the y-axis also we have charges. Coming to the points, these data points is the age group that we'll be having. So as the age group increases, the charges of the instruments also increase. That is what this scatter plot describes. And also this scatter plot is developed with the help of PLT, that is matplotlib. Go to the figure size. This is a decision tree. So it's a visual representation of how decision tree represents. Okay, this is a visual represents how our tree represents and everything. So each box is a node. Whatever seeing each box here, everything is a node. It is a node, and it shows the rules for every box. Okay, whenever they are having age less than or equal to 0.446, less than or equal to 0.728, age less than or equal to 0.533. For every box, you'll be having a rule and meaning. Okay, so if you look at this, plt.figure, figure size for every, like just defining a figure size, and the t.plt underscore tree, dt model, that is defining the model, and feature names is equal to x.columns, fill is equal to true, font is equal to. So whenever it is fill is equal to true, it colors the node based on the predicted values, and the font size makes the text readable. What are the text that you're having? Text, it's making the text readable, and also based upon the values, how much values and what are the values that it is filling, it is giving the color upon it. Also, this plot can be complex for deep trees, but for a maximum depth of 4, it should be illustrative of how the model makes decisions. So if you look at this, you can directly understand that this is what the model is and how it is predicting. So if you look at this, smoker is not equal to 0.5. Smoker, like squared error, this much sample value. If it is true, like he's a smoker. If it is true, then we're going to this. So this plot is the visual representation of decision tree, and it will be a very much example for us to learn how decision tree works. Guys, give me some quick confirmation that my screen is visible or not. I hope my screen is visible to everyone. But if it's not, please text it in the chat as soon as possible. Can you see? Thank you, welcome. So after decision tree, we are talking about random forest. Okay. Now, what is random forest is? Random forest is an ensemble model. So what is this ensemble model? Ensemble model means it combines multiple individual models to make a better prediction. What are this ensemble model is? Remember this thing, guys. So we'll be having ensemble model and transfer learning. Okay. Remember both these terms. Transfer learning is training pre-trained model. What are the pre-trained models that you're having? You'll be training the pre-trained model with your input. Suppose if you look at these Gen AI concepts and everything. So what are the models that you're having? It is a pre-trained model. That means you're transferring the learning. So suppose whenever you go to a classroom, a teacher or a tutor will be present. So this trainer will help you to learn some things. So who is this, like, what is his qualification and everything? He's a pre-trained teacher on specific topic. Okay, just like that. Whenever you want to perform some operations, you can directly take the pre-trained models. Whenever they're open source, you can directly take them and you can make them train on your model data set, and after that you can predict the outcomes. That is what transfer learning is. Coming to ensemble learning, this is a method where you'll be combining multiple individual models to make a better prediction. So, like what we'll be calling, think of it like a forest made of small decision trees. So, multiple decision trees combination is random forest. Okay, in a forest we'll be having multiple trees, right? Just like that, in a random forest we'll be having multiple decision trees. Each tree in this forest is built slightly differently. So, how it is different is using random subsets of data. What are the random subsets of data you'll be having? These will be different. So when making a prediction, each tree gives its own prediction. So for every decision tree, it will give its own prediction. So if you look at this above also, you can see what are the predictions it's giving. So for each tree, it's giving some random unique prediction. And when making a prediction, each tree gives a prediction. That is what we discussed until now. And also then the random forest averages those predictions to get a final, more robust and typically more accurate results. So out of everything, it will make a average. Okay, it will take an average and will take an average. After making an average, it will get the most robust and accurate result. So we use grid search CV again to find the best hyperparameters for this n estimators. So I hope this we have understood this careful cross validation. So just like that, you have used in the decision tree regressor, you'll be using it in the random forest regressor. Okay, we use this grid search CV again to find the best hyperparameters for n estimators. So the reason you are seeing an error because I have interrupted the cell execution. So whenever I start executing this cell, it is taking longer than 20 to 30 minutes. So that is why I stop this. So whenever you stop the cell in the middle, you'll be getting an error. Please remember this thing. I hope you can understand that it's taking longer time. So what we'll be doing is we'll just stop the execution when you click on this book again. So click on the cell again. You can see that keyboard interrupted. This is what we have seen earlier. So whenever I run this model well before, this is what the best score that we're having. Okay. Now what we'll do is just make it common. So now why you are seeing this error? Because the grid CV is not run. So whenever the grid CV is run, from that only we can select the best attribute. So if it is not run, then we cannot select the best attribute. That's why we are making it common again. So we are making it comment again. So that best parameters, that means best combination also we cannot predict that. And coming to the estimators, what are the values that we will having? The best values also we cannot expect that. So coming to this RF model. So whenever we run this without this grid search, that means we are just running the model without grid search. Okay, so whenever you run this model, random forest decreaser is to with a maximum depth of 4, minimum samples 40, and minimum 10, and estimators 10. Okay, so whenever you're running this normally, you'll be seeing these kinds of thing. Random forest decreaser. What are the things that you have discussed? You'll be seeing this. Whenever the model is predicted, you can see the R2 score. Okay, you can see that R2 score is around 0.25 for training data. Coming to testing data, it is around 0.30. So going to other, we are predicting the values of X test. Now we will be taking the now I guess you can understand why we are seeing this error. Coming to this root mean square error, we are keeping the squared is equal to false. What we need to keep is squared is equal to true. Whenever you're having a mean squared error, and inside if you only mention squared is equal to true, or if you don't remember this thing, then only you will be getting a value. Without this not mentioning this thing, you'll be getting an error. So if you look at this, I have removed this squared is equal to false. I have only removed squared is equal to false. Then I can understand what it is having and why it is coming. So now I'm printing all the evaluation metrics, that is root mean square error, R2, mean absolute error, and mean absolute percentage error. Now if you see, root mean square error is 104, and R2 is 0.30, mean absolute error is 7712, and mean absolute percentage error is 1. So that means this regression, what we're having, is not best fit whenever you're not using grid search. Okay, because if you look at this decision tree, just like this decision tree, you will be having multiple. Okay, we'll be having multiple decision trees for every random forest. So whenever you're using random forest, you need to evaluate training and testing multiple times, just like using cross-fold validation. You need to cross-fold validate every training and testing to get the best accuracy. Okay, so when you'll be doing that, you'll be having best accuracy than this thing. So what you'll have seen right now. This is a random sample. This is a random data that we'll be having. So this random data is not the best outcome. Okay, so going to the next model, that is AdaBoost. Okay, going to the next model, that is AdaBoost. Now this is another powerful model in ensemble techniques. So AdaBoost, that is adaptive boosting. Okay, remember this thing. AdaBoost is adaptive boosting. Adaptive boosting is another ensemble technique. It works by sequentially building a series of weak learners. Okay, so what are the weak learners that we're having? It is best for building a sequentially. Sorry, it's best for building a series of weak learners. Okay, so each subsequent learner focuses more on the samples than the previous learner got wrong. What we'll be doing is, like, it not focus on the what are the things that we have got wrong in the previous thing. We'll focus only on the learnings. Okay, whenever we focus on only learnings, it will boost the performance by giving more weight to difficult to predict instances. And also, if you look at N estimators, these are the number of weak learners that you're having. And also, learning rate controls how much each weak learner contributes to the final model. So, a small learning rate requires more estimators, but can lead to better accuracy. Okay, so excuse me. So it controls how much weak learner contributes to the final model. So what is that? This learning rate. How much learning rate it is. So just like that, contribution is done by weak learners, that is predicted here. So that is defined here. And we use grid search CV again. So we use grid search CV to get the best training and testing split for AdaBoost. Okay, as in the name you can see, it's adaptive boosting. We use the best. Okay, let me just make a comment. Let me just run this thing. And for every line, whenever you're having grid CV, you need to make it comment because it will again throw you error. Now, if you run this thing, you can. So we need to perform some data pre-processing, and I hope you all know that we don't have the time. So let's just comment it right now. So this is a process where we are training the model on external bytecode. Now again, we're training the model. Sorry, we are getting the score on extension y-test. Okay. Now at last we are predicting the model. After that, we are getting the values, that is mean absolute square error, mean absolute error, root mean square error, and everything. Now we'll be getting the values. After that, we'll having a plot. This plot shows how the values are scattered and everything. Okay. Now coming to the KNN. This is the algorithm that we have learned recently. Okay, it is known as KNN. This is a simple instance-based learning algorithm. Okay. So this is a non-parametric lazy learning algorithm. This is also known as lazy learning algorithm. Lazy learning algorithm. So it doesn't explicitly build a model during training. When asked to predict a new data point, it looks at its k nearest neighbors, closest data points what it is having, and in the training data and averages their y values to make a prediction. The key parameter what you're having here is k. So this k is nothing but the number of neighbors they are having. So the code iterates through different k values from 2 to 24 and uses cross validation to evaluate the R square for each k. So using cross validation, we will find the best k what we will be doing. Also, this plot what we're seeing in the thing that is behind. Okay, so that we'll be discussing. But first, we're just checking the R2 scores, and for k in the 4 to 25, we're checking the number of neighbors, k, R2 score, and everything. After that, we're having a plot. So this is what we're discussing until now. The plot visually shows how the R square changes with different k values. Okay, so with the different k values, so this is the different k values in the x-axis and R square in the y-axis. So when the k values is at 6, we're having more R2 score. But coming to whenever the k value is increasing gradually, it is decreasing the R2 score that we're having. Okay, I hope you understood this is kind of a proportional or inversely proportional kind of theory where one increases and another decreases. Okay, now if you look at this, at 6 k value, R2 score is greater, but coming to this 18th k value, R2 will be lesser. So not only 18, if you look, even if you look at this 12, that is only just 4 numbers or 5 numbers away from this. Actually, 6 can, which is away from this, is having better accuracy than other things. Special plot, we select an optimal k. Oh, so here we select 9. Okay. So here we select 9 and train our k neighbors regressor our model. So we then evaluate its performance using our standard metrics and visualize the actual versus predicted values. So what are the important ones that we'll be having? So we need to evaluate its performance before scanning out metrics and visualize the actual or predicted values. So if you look at this, we have R mean square error, R square error, mean square error, and mean absolute square error. This is very larger than the sun which I have seen previously. So the next thing we'll be learning about is stacking. Okay, so this is a stacking. What stacking is and what we'll be doing with the stacking and when we'll be using this. So stacking is a advanced ensemble technique. Okay, instead of just averaging predictions like random forest, what it is doing, it is stacking trains on metal model. Okay, level 2, 1, level 1, 1, some like that. Okay, so here as a level 2 model, what we'll be doing is it learns how to best combine the predictions of several base models. So as we're using ChatGPT and some other AI tools, these are the basic plans. Okay. So whenever our basic plans completes and whenever the company doesn't need our data, it will directly sell the data. So if you look at this level 1, the list contains our base models We're using linear regression, KNN, SVR, and another type of model. So decision tree, random forest, and ladder bush. So this is the models that we'll be using, and based upon the models, we'll be performing the operations. For k in range of 2 to 25, number of neighbors k R2 square of k minus 2. Okay. Now here, wells contains our basic models. That is what L1 is. So L1, L2. This is our meta model. It takes the pictures from the level, which moves on its own input features and learns how to make a final prediction. If you look at this, these are the Ks that you're having, so number of neighbors. So as the neighbors are increasing, the values are decreasing. And when the neighbors are stable, the values are equally mostly stable at these 2 points. The idea is that different models might capture different patterns in the data, and by intelligent combinations, we can achieve even better overall performance. So what we're doing is we just use cross validation to again to get a robust R-squared score during timing. Those we predict on the test set and calculate all of our evaluation metrics. This will set us the actual spectral plot for the stacked model will give us a visual data of the performance. So important message what we're having is let's create the potential errors of SME. What are the potential errors that we're having? We need to create. So this is the R2 score for KNN. Same like just you're seeing this 6 is up and 9 is around some line, but I think 9 is visible right now. So this is what we will be discussing until stacking. So next we'll be doing this model comparison. Okay, this is what all the steps. Here we are training again. Okay, and here we are testing. After that, we are breaking the test exist. After that, we are like evaluating the performances and everything. Now we are doing this root mean square and every value that we are having. So now it is giving us a plot. So now, as we are discussing about stacking, let me show you what the stacking consists of. The first level, we're having linear regression. Second level, we're having k-nearest neighbor. Third level, we're having support vector machine. Fourth level, we're having some random algorithm, and also we are having a decision tree. So based upon the depth, everything will be considered this thing. Also, SC underscore model is equal to stack model dot fit, and stack model dot predict. Everything should be done with the help of this SC underscore model. And coming to the score is called the cross validation score. Stack model score is around 0.87. Extension wide scores are 0.90, 0.74. And the scoring of R2 is not mentioned right now. So what are the things that we're having? We're just need to run every model before running this thing. So I think I might have skipped few things. So whenever we skip these things, we need to make sure we run these things again. So if you look at this R-square training data and R-square test data, you can see these are the metrics that you're seeing. Okay, so the metric shows that 0.86 and 0.88 are the evaluation metrics of training and testing. So root mean square error, R2 mean square error, and mean absolute error. So these are the like error metrics that we're seeing. So even if you look at R mean square error and R2 are like mean absolute error, mean absolute percentage error. So these are the values. Based upon the values we'll be using, we'll be fixing whether to use scat like static plot or some other plots. Okay, so if you look at this plot, the plot is somewhat in this kind of shape. Okay, now when we draw a line like this, You draw a linear line in this format. So every point that we'll having mean squared error, mean root mean squared error very less, because what is the line we are drawing, which is almost nearer to this data points. So how this stack regression works, it may show in the screen. So I hope you all know what is a burger, what is a like salad and everything. So if we think about something like salad, we'll be having a bread, and on top of bread, we'll be having another bread. And if you're a bread lover, you'll be having another bread. Okay. So the first thing, this is linear regression. Second thing, that is decision tree. Third thing, that is random forest or some other algorithm like SVM. So I hope I understood. Whenever you're eating some burger also, in every burger you'll be having multiple components. Okay. In every burger you'll having multiple components. Each component represent a separate item. So one will be tomatoes, one will be lettuce, one will be chicken or aloo. Okay, one will be bread. So you'll be having 4 items here. So every item is stacked upon each other. It means every item is placed. So just like that, we'll be having a stacked algorithm where every algorithm is placed upon each other. Now, we're not discussing about ensemble learning. I just gave you a glance of what is ensemble learning. So as we're discussing about the topics and the models, I just thought of giving a glance about what is ensemble learning is. So now I hope you understood this thing. So these are the levels of this stacked model. So linear regression, KNN, SVR, and decision tree. These are the 4 levels of this stacked model. So going last, analyzing what is the outcome of this every model. You can see that R2 score of test and train, RMSE, MSE, MA, and MAPE. So from that, we can conclude that stack regression is the best model that out of these 4 models. So what I'll be doing is I'll be having a list and I'll be printing it. So what is the list? Linear regression, extended regression, KNN, stacked regression. These are the levels of what is the outcome they have got. So let me just reverse the list, and why I have reversed the list is because to get the plot. Okay. So if I didn't reverse the list, imagine I didn't reverse the list. This is what I'll be seeing. Okay, imagine if I didn't reverse this list. I don't know why it is taking a longer time. So let me show you reverse list, and I hope you understood the execution. So we're using a model here. Okay, so what is the model that we're using? If you understand, you can see that stack regression has stopped every model. And after that, decision tree is slightly closer to this. Because in decision tree regression, we are using grid search. Okay, remember we are using grid search to get the best combination of inputs. Okay, we are doing hyperparametric tuning in the beginning itself. So when you are doing this thing, you're getting the best outputs and the best, sorry, not the outputs, you're getting the best inputs for training the model. Okay, that is what you have. That is the reason you are getting decision tree this much of accuracy. So whenever I'm mentioning accuracy, that is what I mentioned. I'm referring to metrics. So I've been habituated with the word of accuracy. Don't confuse with the accuracy that you're seeing in classification. So whenever I'm mentioning this accuracy, please understand that I'm mentioning to metrics. Okay. So coming to models. These are the models and these are the R2 scores. So you can see that R2 scores of the model that you're having is this thing. So overall R2 score that you're having is overall stacked regression model outperformed dictionary regression, and R2 score is 88%. Okay. Now this stacked regression that you're having, it outperformed dictionary regression, and linear regression and Kenan is nowhere near them. Okay. So Kenan is slightly near, but linear regression is nowhere near to the model. Okay. Now this is what the overall thing is. Now what you'll do, now whenever you're done analyzing multiple models, now you need to take single model. Okay, the single model which you're going to take is stacked regression. Now you need to take this stacked regression and you take a pickle model out of this. Okay, I'll be showing you out of the code how it is. So I've written a code where I'll be taking the best model. So import pickle. This is a file pickle. So best model index. So here we're taking R2 score and best model name. Here we take the model name. If model name is equal to linear regression, then we'll be taking the best model as linear model. If it is dictionary, we'll be taking DT model. If it is random forest, we'll be taking RF model. So based upon the R2 score and everything, we'll be taking which model got the best thing. So if no model got the best accuracy, then we'll be taking could not find model. No, like could not find any model. So here, what we'll be doing, if best model is not none, file name is equal to F best model name. That is, as we have discussed, we have the best model that is stacked regression model. Hope you can see this thing. I have already done this. So what you'll be seeing is stacked regression model dot replace dot clover of model underscore pkl. That's what pkl refers for. So with often file name wb as if pickle.dump. So whenever I write this code, it will automatically dump it this. And coming to this, we are printing this thing. Okay, and also you can download this file whenever you run this function. So it's a form of code that we'll be using Flask. Let me just explain you another notebook before going to the Flask. I hope you have enough time. I'll be explaining Flask in 10 minutes. So this is what the model is. This is how it download pickle. So let me just run this cell. I'll be sharing the data. Don't worry about this. And I hope you all know that from the next week, we'll be having a project development course, not the course, product development classes. And I request everyone to go to the SME portals of Smart Interns. Okay, whatever the portals that you're logging in. So open these portals, and in those portals, you'll be having an understanding of what are the self-paced course you'll be doing. No, not as it is. So in this product development class, what you're having, we will give you the time to develop the project. Okay, if you're having some method, you can contact us, or if you're having some difficulty, our team will help you regarding the project outcomes and how to develop the project and everything. So based upon your needs, we'll be moving on with this project development. And as we are count of around 30, we'll have a mentor for you. Okay, so don't worry about the thing. This mentor will take care of you. What you'll be having this 2-hour class every day. So in this 2-hour class, what are the topics you feel difficult to understand? She or he will explain them, and also he or she will help you to understand the project a little bit. Yeah, you can ask this doubts or some other thing in the 2-hour session. So this 2-hour session is completely given for your project. No theory will be told by the trainer. You can ask your doubts, or if it is possible, they can explain the project once again. What are the things that I'm doing right now? If you want, they can explain the project. So based upon that, you can create a new project for yourself. Okay, I request you to take a break of 2 minutes. In the meanwhile, I'll be preparing a new notebook for explaining. Now you'll be selecting the project in the portal. You'll be having the Smart Interns portal. In this portal, you'll be selecting a project. Okay, so everything will be explained in the upcoming class. And I request you all to go to this portal and see the IBM courses. we have added a IBM course. So I request you all to go to this portal and check out these new courses that were added. So please let me know that you have checked this course. I'll be getting a poll. I think it's not necessary to create a poll. If someone from you checked the self-paced course, I don't have the link, but in the portal, whatever you're having in the self-paced course, there is an option that is called a self-paced course. In that, we have added IBM. Okay, just like machine learning, what you're doing, we have added IBM. So in that IBM, you will be navigating to the window and you will be completing your courses. Okay, these courses are officially provided by IBM. As we are in collaboration with IBM, we have provided this course material also. Okay, what are the IBM courses that you're having? These courses are regarding prompt engineering, regarding introduction to artificial intelligence, like regarding the generative AI, and also some courses might include agentic AI also. That's the current AI development that we're having right now. So as we are in the beginning stage of AI, we are helping you to learn about more with the help of the self-paced courses. I hope you understood this point. And I request you all to fill a feedback form that I've shared in the Telegram group. So let me just take a minute. Come back within 2 minutes, no more than 2 minutes. So in the 2 minutes, have some water and come back. Guys, I hope my screen is visible to everyone. I have shared the ID right now. I have shared the flash code. Give me some response in the chat. Can you see the screen? What are the screen? What are the screen I'll be sharing? Can you see this? So thank you, Gautam, for the response. I think there won't be enough time to explain everything. So let me just give you a quick recap what is Flask and everything. So I don't call it a recap also. I'll just give an overview on this thing. So I'll assure you in the next session, my mentor, whoever will be handling the session, will help you with the Flask. Okay. So even if you don't understand by the mentor, again, we'll be having a one-on-one session like the session what we're having right now, and we'll discuss about Flask in detail. So here we need to import a Flask. Okay. So what are the things that you're having is Flask is a library. So from Flask, we'll having this template indirect URL. So joblib is like a like if you click on this, you can understand what is joblib. So just like we are discussing about pickle, pickle is used to download the machine learning file and import it into the Flask. So just like that, joblib is also like lightweight pipeline. So this pipeline will help you to import the machine learning into this Python Flask code. Okay. So this pipeline, whenever you're importing the data, so this pipeline will have this continuous analysis and continuous prediction of the values with the help of Flask code. We're also importing NumPy. This is the initialization of Flask. Okay, this is the initialization of Flask. App is called to Flask __ name. So we are taking this secret key. So why we are taking the secret key is because suppose if you are a developer, be given some account. So for the account what you're using, you need to have some credentials to access the account. So whenever you're having these credentials, you will be accessing the account. So using these credentials, you'll be uploading the code or doing something. So this secret key is the key you'll be having so that you can understand that this code can understand that you're an admin. You're not some other person trying to run this thing. You're the admin. You can make some changes. It's like a hash password. It's like a OTP. Whenever having the secret key, only the secret key, only when you're having the secret key, then the code runs to the particular destination where you want the code to be. Suppose if I'm running this code using my Flask, using my API. So I'll be replacing this secret key with API. Okay. Now here, I don't have this model right now. This is another model. I need to download it, but we don't have enough time. So let me just give you an overview. This is a model. So what I'll be doing is joblib.load. So it is a path of the model where it is. Okay. Now this rising times is what this project, this Flask code represents what is the ML model that we're discussing right now. This is not the insurance that we're discussing until now. Okay. This is not the insurance that we are discussing until now. This is a sample model of dry fruits or some other thing. Okay. So rising types, Kesimen or Besni. So this is what this thing. So app _ root. This is the function that we will be defining. So whenever you want to define a root is nothing but the initialization of a function. Whenever you want to define an initialization of function, so in every HTML page, sorry, not in every HTML page. So whenever you're using Instagram, first you're using sign up page. Okay, that is a root. Okay, this sign up will hold a function. Sign up will hold a function. Okay, this whenever you complete this function, we'll be using that with the help of /signup /signin /. Okay, now what are the slash represents for? This slash represents home. Whenever you're having this /register /something, this represents particular page or some other thing. But coming to this slash, whenever the slash is represented and without slash, after slash or before slash, there is no text. That means this slash represents the home page. Whenever you open something, whenever you open YouTube, you'll be seeing some home page. That is what the slash represents. Okay. So in that, you're taking the function, you can see that if home. That means we are predicting the, we are defining the home function. Coming to the registration page, here we are registering as our user. So what you'll be doing is if request.method equal to post. That means whenever we're having two methods, we'll be having two methods. In the home page, we won't have any method, but coming to register, we'll be having two methods. That is get method and post method. Get method is for showing the data and post method is for posting the data into database. Okay, you're having two methods. Get is for showing, post is for placing the data into database. Okay, or taking the data from user. Now what we are doing is def _ register. So we're defining the function. After that, we are doing this request.method. So in this, we are using post function. So in this post function, what we are doing, name, username, email, password. We're taking name, username, email, password, and we are posting them in the database. So from where we are taking request.form. We'll be having Google form, right? For every, like whenever you're typing your sign up email ID and password, that is what we call form in HTML. Okay, we call that form in HTML. So from form, we are taking this email ID, username, password, and everything, and we are storing that in database. If username and user will have this username already exists. This is the case when even though you already have an account, you'll try to sign up. Okay, you might forget that you have already an account in this particular domain. What you'll be doing, you'll be trying to log in again. So at that time, you'll be receiving these kinds of things. Username already exists. Please go to this page and log in. Okay, this is the anchor tag. So I hope you understand what is anchor tag. And it is hash password. It is generating some hash password. So after that, we will redirect to login once we have signed up. Okay. And after that, we will register to the, sorry, if not, we'll go back to the register template. So whenever you're seeing this redirect for, there are two ways. Render template. That means we are rendering the template. We are taking the template and we are showing the template. And coming to redirect, redirect is, I hope you already know what is the meaning of redirect. It is directly redirecting to this template. So it's a sample code, just like the function what you're seeing at the rate app.root. Okay, for every major function, we'll be having this thing. Okay, suppose let's take an example of Instagram. In Instagram, what is the thing that you'll be doing? If it is logged in, then no problem. If it is not logged in, what is the thing that you'll be seeing? Home page, that is slash. After that slash, you'll be seeing sign in. That is one slash sign in. Okay. If you don't have an account, you'll be having the option create account in the bottom. Okay. When you click on this create account, slash create account. That is also an option. That is also a root. After that, you'll be seeing some functions like user profile, user likes, user count, and everything. Okay. Every user likes, user count comes under user profile. So for every major function, you'll be having an app root. Okay. Now if you look at this app.root, you're having this for login. After that, you're having this for predict. Okay. After that, you're having this for predict. Here we're using the model. Here we're using the ML model, and you can see here we're trying to take the input features in predicted class, probability, resin type, and everything. Now after that, we're writing the template predict.html. Resin type is equal to resin type, probability is equal to probability. So here, what we're doing is we're taking the input features and we're passing the input features to this model, the model where we have uploaded. So as we have taken this model will take the input features what we're adding here. So what are the inputs that we're having? This inputs will be sent to this model, and when these inputs will be sent to that model, this model will have some mathematical calculations or some processing in the backend, and after the processing is done, we'll predict the values. That means we'll predict the outputs. Okay, so at last we're having this logout. Okay, as we have told, for every major function we'll be having an app root. So app.root at the rate app.root slash logout diff logout. Okay, for every thing also we'll have a function inside. For every major function we'll having a mini function. Okay, session.pop. For every login you will be creating a session. So let me show you what the session is. So I hope everyone can see my screen. So these are the sessions that will be having. Okay, look at this. These are sessions. So what is the session and why it is stored? And if you look at this, it is stored in Google. I hope you can see my screen, right? You can see my Chrome tab. So to get this, you need to click on Control Shift I. Okay. So whenever you click on Control Shift I, you'll be navigated to this application. And when you click on application, you'll be seeing local storage, session storage. So whenever you go to the session storage, suppose imagine this is an Instagram application. Okay, imagine this is an Instagram application and you have logged in with your username and password. Now a session is created. Okay. Now what the session does is, what are the activity and how much time you have logged in, this session will remember everything. Once you log out, this session will be deleted. What the session is? Session is nothing but the login time and logout time. Okay, from how much time you have logged in and from how much time you have logged out. So if you can see in my Chrome, I have multiple sessions because whenever I try to log in, I'll forget to log out everything. Okay, so these are the multiple tabs I have right now. Mostly of collab, and I have a feedback form. Okay, so for every session that you're having, that means I have logged in and I didn't log out. This is what the session is, and this is what Flask code is. I hope I just gave an overview of what is Flask. Flask is a lightweight Python application. So by means of Python application, it is built upon Python. Flask is a thing that is built upon Python. So unlike Flask, we have other applications also. So these are Fast API. So if you want, you can perform the coding in Fast API also. And remember, this is a web framework. Okay. Why we are using? We are using this to connect the backend and front end. This is the backend code, and the front end code is the HTML page and everything. Now you might understand, you might get a doubt what is the model comes under. Model also comes under backend, but this backend code, what you're talking about, the Flask, is the main backend coming to the model. That is a part of the backend, not the entire backend. Okay. So whenever you run this code, you'll be getting a local IP that is 127.0.0.1 for the port 5000. Okay. So whenever you run this code, you'll be having this 127. Let me just show you with the sample. If I have any folders, I can show you right now. I think I don't have any files right now, and also we're running out of time. Class, if you're having any doubts, you can ask me right now. And please give me some response that you can see the IBM self-paced course that has been added to the portal. So I got the confirmation that the IBM self-paced course have been added to the portal. So I need some confirmation that you all can open the self-paced course and complete this IBM. Once this IBM self-paced course is completed, I'll be sharing a feedback link in the group. So help us understand how this course felt for you and everything. So Radhika, I hope you have logged in with this. So if you can see, this is what the portal looks like. And I hope I have account. Let me just how to use this account. Just go back and sign in. I hope you all can see this thing. This is the account that I'm talking about. In this skill wallet, my skill wallet, we have added this machine learning course for you. So in this courses, I have two courses. One is machine learning crash course and one is IBM skill build. So what you have done is, until now, you have completed this IBM skill, like machine learning course. Completed this IBM skill build, it was only a duration of 45 minutes. Now, at the topmost priority, I want everyone to complete this IBM skill build. And I want the completion images or the completion screenshots from everyone. Okay, now you can log in with email or Google. So just follow the basic steps that we'll be having. And I'll be sharing a Google form. And once it is done, I want you to reply in this. So if it is having some technical issue, let's wait for a few more time. and you can have the time until Sunday. Yeah, until Sunday, you can complete this thing. I hope you all have this IP at like the link address. May share it in the chat, and I'll also share this in the Telegram. Whenever you complete this thing, I need you all to fill the feedback, not the feedback. I want you all to fill your response in this Google form. So what are the IBM courses that you have completed? So for that, you need to take a screenshot and fill that with the help of Credly link. If there is no field for image, you can directly paste the Credly link. And if you're present in the meet still now, fill out the feedback form. What are the feedback that you're having in the Telegram? I want you all to fill the feedback. And thank you guys. It was a great session. And I hope you all know this was the last session for today. I have also shared the feedback form in the chat. I'll be in the meet for another few minutes. Thank you, Shubham, for your kind-hearted words. Thank you, Hariom, as you as well. You were very active in the sessions. And I hope you understood a lot of things from the sessions. So I'll wish you all the best. And if you're having any doubts, you can just ping us in the Telegram. Thank you, Anjali. Yeah, you need to have an IBM learning account. This is for the development purpose. So you need to have this IBM account. So about the projects version, what are the platform you're having? That is Skill Wallet. In the platform only, we'll be uploading the projects. Okay, so in the group projects, you'll be seeing some projects, right? You'll be seeing 4 projects. So from these 4 projects, you can enroll one of the project and you can start working on this project. Or if you want to perform your project on your own, you need to take some permission with the mentor, whoever it is assigned. So you need to take the permission from the mentor, and then you need to proceed if they allow you to take some own project. Okay, guys, if you're having any queries, then we can continue. If not, we'll end the session. I hope no one has query rest.